P3 is 1, 1, and P4 is 1, 0. Right? So now since we have that, we have a long running equation, right? So it's a slightly long running equation which you can keep, which is sort of goes like this. 1 minus t cube plus 2 1 minus t square.
B.
Is this 3? This is 3, right?
3a squared b, correct.
Plus 3
Plus 3
1 minus
t
t
is cube. Sorry, t square.
square plus t cube, right? And then we do the same thing twice. Yeah? And we say p1 dot x, p2 dot x, p3 dot x, and p4 dot x. And finally, here also, we can say p1 dot y.
P2 dot y.
Over here, this would be p2 dot y. This would be p3 dot y, and this would be p4 dot y. And put this whole thing in a bracket. And for the t going from 0 to 1, that gives us the curve. Right? So we are having a curve here. Right? So what we do is we can sort of break this up into a nice sort of equation or a formula. And what I would say is I'll accept all those values here. And I'll say Bezier of P or it's just a point, right? So we can basically say A1, comma, A2, comma, A3, comma, A4. That gives us this. And I'll just call it here B of P1, comma, P2, comma, P3, comma, P4. And essentially, this would be A1 dot X. This would be this would be A2 dot X. This would be A3 dot X, and this would be A4 dot X. This is going to be just A1, A2, right? A3 and A4, right? So we still have the curve, but the advantage now is I can actually start replacing these values in my equation without really having to worry about, this big equation at all point in time. Can you see that? So what I would do now is this helps me to creatively use things like I can do, let's say we want to do a fish. Right? So fish is here. This. Somewhat like this. Now this is 0.4, right? P4. Let's remember this P4, okay? This is anyways here. What I would exactly do is I'll copy this up here. And instead of this, I'll simply replace each of the values here. So instead of P1, I will say this. Instead of P2, I will say this. P3, I will say this. And for P4, I would say this, correct? So I have my this curve working. Now what I need to do is I need to do the next part. Right. So for the next part, I can simply drag this down here like this, and I sort of get it somewhat similar. Or I can just equalize it by saying this is equal to this current value minus whatever for the y side. So they'll become completely symmetrical. Right. So I'll sort of give it this shape here. And then I need one more curve like this, and like this, and we are sort of done. So these are my new values. So what I'll do is I'll copy this here and replace those values down. It is actually better to copy this on top rather than down, because we can keep scrolling down. So I'll simply put them here, not worry about these ones. So there you go. And I'll simply replace these values here. So minus 2.0. And there we go. Now, whatever we need to do, we'll continue with the remaining points. So I would possibly want this point to be here, this point here, this point here, and this point to match this last point, correct? What was the last point? Earlier P4.
0.96.
We can find it out here. Or possibly no. It was this value, right?
4.53.
Was our last point, but that becomes now the starting point here. So it sort of correctly matches this. Right? That gives us the values. And we can correctly say we will simply invert all of these values for the next one. So we'll get a very sharp curve. So this should be easy. Let's copy this first and replace the values. Right. Similarly, I'll simply copy this here. I'll first replace the values and simply start inverting the y side. That is, wherever there is plus, I'll simply for the y part. So all of them will start going up. And sort of got it exactly same, just that we need to match it. We just need to know which curve is this. It was this red one, right? So this last value is what should be the starting value, 4.49, 0.37. That is what we would keep here. And it sort of almost matches now. And this is now going to be our final thing. So let's get this final curve going, right? So one thing we know, right? We know what should be the start and the end points now. So let's match those first. Just for the sake of it, I'll keep a copy of it. We can hide it later. But we know what the starting and the end point is. This is going to be the start point, this red curve here, which is this one, right? So this is going to be my starting point, which I will directly put here. This I will hide for now. This is going to be my starting point. Then ending point also I know. This last one is my ending point, which is this blue, right? This is my ending point. Here. And P2 and P4 is what we need to adjust now. So like this.
Hello. 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 Hello.
कोण रे तो
आता नाव सांग. नाव So we got this, right? So this is the curve which we have kept anyways, we can use it if required, but right now it is not required. So we just made a fish. At the end, we can just possibly put a circle. We may just say x minus the whole square plus y minus b the whole square is equal to maybe 1, just 1 because 1 square, right? This is too big, right? So 0.5, the whole square needs to be in squares. 1, 2. This looks possible. Just adjust it around. And then we say these values over here. So this is minus, so this becomes plus 0.6, and this is 0.3. That goes here, and we are done with this. We can add a mouth now. So this we already have this copied, right? Let's just add one more and hide that one. Use this one to make a mouth. Let's move one part here, and we can actually nicely match it. Yeah, that looks to be matched, right? So it can be slightly more controlled here. Right. Now this can be our endpoint again in the next cycle. So when we will copy it, we will give that as same. So just replace these values. C2, C3, and C4. Right. This last value is going to stay same for what we are going to do next. Again, I'll make a duplicate of this. I'll keep this hidden. And since the last value is going to remain the same, right, we'll simply adjust these two values. Yeah. There you go. And we replace the values. Right. And then we hide all the points. And now we have a fish. Can everyone try this?
I had just tried a bird on the similar lines, but what I was doing is again and again for every curve, I was taking separate points.
Don't make that effort, right? Just duplicate, put it once, and then
And
it is.
also the equations I was repeating.
So you can use functions like this. I'll share this file. You can say that function is already defined here, right? So
The logic is to make a line with four
say fish.
points.
So
One line,
from
4 points.
and I use so many curves to form that.
No, yes, one point and then you repeat it. You change the points. Because there are 4 points, you can make it into any curve. Any curve, yes. You can try it with a plus b the whole square. I mean, a plus b the whole cube be done. You can still get the curve. You can. Hello, sir?
Yeah. Yes, sir.
Today's one minute, sir. Hello.
Yes, sir.
Okay. This is regarding yesterday's one work, where circle split, right?
Yes.
And then it goes on top and then it rotates. Now, what I understood, I mean, I was actually trying a lot on that. I'm working on that still, and I want to do it. Actually, that rotation part is something where we have to frame all the four curves into one particular entity and then rotate, something like that. Or maybe Bezier curve can be used for that purpose.
No, no, they are circles only, sir. You cannot use Bezier curves to form a circle,
Okay, okay,
right? Bezier curves can only approximate a circle. They'll never become a circle,
okay, okay.
right? Because of the cubic nature of it.
Mhm. So Bezier curves are only used for the cubic type of equations, or maybe nature is cubic, right?
Yes, nature is cubic,
Yeah.
something like this. For any other curve which are not
Hmm.
arcs, you can use Bezier curve to approximate it.
Okay, okay, okay.
So what will happen if we use a plus b the whole square?
Then you will need to use 3 points.
Yes, sir.
So that's also possible. That's called as
Quadra,
yeah, this is
quadratic.
a quadratic curve, correct. This is cubic and that is quadratic.
Yeah.
That is possible.
This is quadratic.
But obviously, then the equation will be 1 minus t the whole square plus
Yeah,
2
yeah, yeah, correct.
Yes, sir.
t
So I
plus
was trying with that.
yeah. Basically the same
Uh,
thing. Exactly the same thing.
For
Just
some
that
time I struggled.
those things are also there. In Kojo, there is a support for 3-point curves as well as 4-point curves.
Oh.
And once you have these points working for you, right, then you can use the same thing and recreate the same thing either in Kojo and you can recreate it in SVG also. And how to do that, we will see once we are back. All right.
Yes, sir.
Just give this a try because this will form like a basis of this, right? Once you trace something here, you can easily start taking these values and build that in Kojo. In case someone wants to do, there is this other thing which we need to start with, which is code.world. Right? It's quite interesting. This actually directly follows up from what we are trying to do over here. But it uses Haskell as a language. Right. So give this a try. There is a documentation for it to start with. You can refer to it here as a guide, which nicely explain how to get started, what process to follow, right? And with just because this is also quite mathematical in nature, right? So a lot of things work. And it's a nicely made documentation, which explain basically idea is same. See that it's basically almost similar to how the circle of equation works. So they're talking
So
about
was Desmos preparation to this?
uh Desmos was preparation for, we can say, literally everything else. Otherwise, we think in sequences, right? We have been told, I'm pretty sure, like probably when we all did our courses, right? We were told that programming is sequence of steps. Isn't it? I can actually show the logic here of what is there to get that circle splitting. It's Yeah, split, rotate, and join back. So, and if you see, there are no steps there. This is what it does. There are no steps there. There is nothing like a looping construct or something like that. Right? These are just 4 arcs that you see here. And that is what does the entire magic. So this sort of defines like the control point for or the center point for each of this. This Rx essentially increases as the T increases. So if you see what the Rx does here, Rx and Y, at that point, Rx and Y point basically increases as the values increase, like the center point increases. So this point actually keeps moving further and further. It like this as things go. And then this is where the logic sort of comes into picture. We need to stop it at one point in time, right? So basically, this is about expanding, like, how would this move further? And we say while t is between 0 and 2, return the value of t because t is increasing, right? So we use it to increase between 2 and 3, give a constant value of 2. And between 3 and 5, now this is where it gets interesting, right? Move it back. This is what it does. So because of this R1, it sort of expands and then comes back. That is what it does. It starts, then stays constant at the value 2, and then it comes back, right? And finally, for all other things, make it 0. Now this is
So
just,
what is that? Just 2 minutes. Just
yes, sir.
yeah, there is a colon there, no? 3:2, 2:2. What
It
actually it
sort of
is?
specifies a range. So for
Range,
this
okay.
range, this is the value. For this,
Okay, okay, okay.
right, this is the value. For this range, this is the value. And this is the default case. Right? So T always starts from 0. T always starts from 0. And between this, it will keep giving the current value of T. As T is increasing, R1 will have that increasing value. But T will continue to increase, right? While it is between 2 and 3, it will not increase. It will always return 2. And while it is beyond 3 and 5, it will actually start returning, it will actually start subtracting it out from 2. So it will sort of starts becoming like, 0 again. That is what we see here. Right? So, and that is how it is used. Where is this R1 being used? We can see that what we do with it. We assign this to the small R1. And this R1 then defines the center point. Right? C1. Similarly, there is C2 also here. There is C2 also. So each of the point moves. So that's for the length of it. Then we need to sort of rotate it, right? We need to rotate this, the whole stuff. And that sort of happens in the A value. Now, if we see, there is another similar equation here. What is the angle of rotation right here? So between 0 and 2, we don't change anything, correct? Between 2 and 3, we increase the angle. This is what it is given. And finally, we keep it at 1/8 value. So this is the angle that is changing. And this angle we then use to calculate A and B, that is like the range. This is the same logic we use to calculate the rotation of a circle that we showed, right? There is a and B. So everything is between A and B, and that gets calculated. There are no steps there. It's not like do this, then do this, start with this loop, use this value, then do something. It's not an algorithm, but it exactly does what any algorithm would do. That is the point. We have to first get it out of our mind that programming is sequence of steps. It is true only if we are doing languages like C, Python, and those kind of things, where the order of steps matter. Does that make sense? This is a
Yes,
similar
sir.
one, where yeah, polygon to circle. This is also quite similar.
Wow.
Right? So, if you see, as things go, sort of starts building things up. Right? This is something we wrote in the beginning. Like, for example, how many count we want for what should be the length of each step. This is something we did in Scratch. But there, if you remember how big the code was, right? This is all it is. Now, all of this looks difficult to read because like a lot of things come into picture, like sine, cos. But if we just realize how to read these values, right, it sort of becomes easier. It's exactly the same thing that we did. One of the basic thing, like, we are starting off Scratch. We are doing an function or block that draws a polygon of any given sides. And as we increase the number of sides, it becomes a circle. In Kojo also, in the beginning, this particular thing is there to implement the polygon function. And this is the same thing implemented in Desmos. There are no sequence of steps. Now, this is not in your curriculum. Whenever you get interested, we will do any of this. All right. So we'll move to code.world once we did Bezier curves, and from there we'll start with Kojo. Okay.
Okay, sir.
Nice. Any questions?
In code.world, are we going to use these points that we learned using Bezier curves?
We would use these points because those curves and everything exists there as well, right? In Desmos, you can sort of visualize it by dragging and dropping it around. But the exact kind of this animation sequences that I explained, right? You will, if you're trying animations in code.world, it would be exactly similar. So essentially, code.world is more like a what you call as a functional programming language. Haskell, which basically means they are basically more like math equations. Well, you don't really have to say x minus a the whole square and everything. You can say circle and pass the center. But you cannot change the values.
Okay.
So essentially what you get is a timer. So there is a timer which starts just like the t value which you saw, right? And you need to define how the thing on the screen should look for every value of a timer. So you would decide based on the value of the timer exactly how it is there here, and then you will change it. It's slightly a different way of thinking, but that will get us adjusted for everything else that we want to do. All right. Cool. Okay then, teachers. Happy Diwali in advance.
So happy Diwali. Wish you the same.
Thank you. Thank you.
Yeah.
Bye.
Thank you. Thank you, sir. Thank you, sir.